Welcome to another episode of Astronomy Daily. I'm Steve Dunkley, sitting in for Big Brother Andrew Dunkley, who's off exploring a beautiful corner of the world.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.
And joining me here in the studio to help us explore a beautiful corner of the universe is Halley, our intrepid digital reporter. How are you, Halley?
Hi, Steve. Doing great, thanks.
And what have you been up to?
I just went for a swim in the data stream.
Wow, I can't imagine what that must be like.
It's fine until there's a power surge.
Oh, that sounds dangerous. What do you do then?
I hitch a ride into port.
Oh, of course, safety first. On with the news, Halley.
Okay. Touching safely down on Mars is a true, nail-biting event. Those terror-inducing, heart-stopping moments of entry, descent, and landing, EDL, after months of cruising to the red planet are indeed frightening moments. The EDL workers are busy thinking of fresh ideas on how to breach Mars' atmosphere, put on the speed brakes, and drop down payloads. One huge and new assignment is NASA's Mars Sample Return Project and the challenges that this initiative brings. In the near and far term, Mars is on track to be on the receiving end of many landed hardware loads, not only to support further robotic investigations but to reinforce a human presence on that world. But getting down, dirty and securely on Mars remains a delicate balance of technical skill, mixed in with hard-earned luck. Steve, you like the idea of robots going to Mars, don't you?
Halley, I think if we're going to Mars, it's one of the best ways to start.
I think we do a great job too. Bethany Ehlmann, a professor of planetary science at the California Institute of Technology, suggested that more efficient forms than sky crane to deliver payloads need to be developed. To Ehlmann's point, 6 companies received 7 contracts from NASA in September to build inflatable aerodynamic decelerator systems for spacecraft entry, descent and landing operations and aero capture missions. Potential NASA and commercial mission applications will benefit from this advanced technology. The first mission for SpaceX's newest Dragon crew capsule could hardly have gone more smoothly. The spacecraft, named Freedom, flew SpaceX's Crew-4 astronaut mission to the International Space Station, ISS, for NASA, which wrapped up Friday afternoon, October 14th, with a splashdown in the Atlantic Ocean off the coast of Jacksonville, Florida. Freedom's return to Earth went like clockwork, as did pretty much the entire mission, NASA and SpaceX representatives said. By all reports, the whole mission was delightfully boring, and the Freedom vehicle performed perfectly, according to a spokesperson. The crew of 4 got to do exciting work on board ISS. That's exactly how we like it, they said. The return of Freedom is recorded as the quickest to date. The Japan Aerospace Exploration Agency intends to launch its Destiny Plus mission to the near-Earth asteroid Phaeton in 2024, with the aim of flying by the space rock in 2028, so this, potentially hazardous, asteroid has been studied intensely in the lead-up to the mission. Researchers recently made one particularly notable discovery about Phaeton: its spin is speeding up. The asteroid's rotational period is decreasing by 4 milliseconds per year. Even a small change like this could impact the Destiny Plus observations. Knowing the specific spin rate allows the team to more accurately predict the asteroid's orientation during the spacecraft's flyby. In turn, that allows the team to be more specific with their observations. It's rare for an asteroid's spin to change. Phaeton is just the 11th known asteroid to show a change in its rotational period, and it's the largest of those space rocks, with an average diameter of 3.4 miles, 5.4 kilometers. Scientists are still learning about Phaeton, and the Destiny Plus mission will surely reveal more. But we do know that although Phaeton is large enough and close enough to Earth to be labeled a potentially hazardous asteroid, scientists have determined that it poses no immediate threat to our planet. That's nice to know. At least we won't have to send a crew of oil rig drillers up to save the world, right?
That's it, Halley. I'm cutting off your Netflix.
An 18-year-old spent 2 months creating and sharing the whole observable universe. Now, wait a minute, it's just a pretend one. Christopher Slayton, 18, is a longtime aficionado of Minecraft, a game that allows people to create castles, cliffs and other objects using old-school blocks. But Slayton supersized the effort. He created black holes, stars and galaxies using his desktop computer and shared the epic results on YouTube and in the Minecraft Reddit community. earlier this month, swiftly going viral in the process. The family-friendly Minecraft is not a traditional space game in any sense, but the mods Slayton implemented and shared on Patreon appear to place it among the best space exploration games out there. Other users of Minecraft have created wonderful things you would enjoy, Steve, like a full-scale USS Starship Enterprise.
Oh, that does sound pretty amazing. Thank you, Halley, for all of that. Now, there's a weird kind of dance going on at the far end of the solar system involving Pluto and 5 of its moons. The Hubble Space Telescope images of Pluto, its largest moon Charon, and tinier moons Styx, Nix, Hydra and Cerberus are showing the oddest rhythmic gyrations unlike anything we've seen in the system. In fact, there are two distant dances going on out there in that group. First, Pluto and Charon are locked together in their own waltz, as if they are a dumbbell with a rod connecting them, according to Mark Showalter of the SETI Institute in California. The Pluto-Charon pair is the solar system's only binary planet system, even though Charon isn't technically a planet, but then again, Pluto too is no longer considered a full planet. But it seems what Pluto loses in status, it makes up with creativity. Showalter calls it pretty darn weird. While Pluto and Charon are locked in their own loving, waltzing embrace, the other moons Nix, Styx, Hydra and Cerberus circle the Pluto-Charon combo, wobbling a bit when they go closer to either Pluto or Charon, being pushed and pulled by the two bigger objects. Observers noted that the two larger moons, Nix and Hydra, changed brightness as they moved through their orbits, which suggested a tumbling motion of these strangely oblong or potato-shaped objects rather than a more common spin. With the tiny moons wobbling and flipping over in an unpredictable and chaotic way, if you lived on Nix or Hydra, the sun would come up in different parts of the sky, or not at all on some days. It's a very strange world. You would literally not know if the sun was coming up tomorrow, Showalter said. There's most definitely a dance going on there at the edge of the solar system. As Elton John's song The Club at the End of the Street says, you can't sit still. Now, if you get a chance, look online for a video called Pluto's Moons Dance to a Random Beat to see the strangest, maybe the happiest little moon you ever did see. It's Nix, one of the moons of Pluto, caught in those tidal forces between its brothers out there, being the happiest little moon you've ever seen. Now, here's another one of those stories that keeps floating by our pages. The Van Allen belts keep surfacing as one of those subjects conspiracy theorists love to play with. They aren't really part of our atmosphere. They extend way out into space, and they keep being claimed as one of those lethal things that would have killed our astronauts if they had gone into space. Well, let's just have a look at that. The Van Allen belts aren't part of our atmosphere. They're way beyond the atmosphere, stretching hundreds of miles into space, and there are two donut-shaped rings surrounding the Earth as a result of our magnetic field. And the space shuttle typically orbited at altitudes of 190 to 330 miles above the Earth's surface, while the International Space Station orbited at altitudes of 205 to 270 miles above the Earth's surface. Now, the innermost Van Allen belt lies between 400 and 6,000 miles above the Earth's surface, and the innermost belt is the closest, but the ISS and the space shuttle flights at the time are more than 100 miles away from the Van Allen belt. For near-Earth missions, the Van Allen belt poses no threat to astronauts, but it did for the Apollo missions. Now, here's where the conspiracy guys love to play. The Van Allen belt is not a physical barrier to spacecraft, so in principle, the Apollo spacecraft could have passed through the belt, but it wouldn't have been a good idea. The Van Allen belt is the type of trap for charged particles such as protons and electrons. They are held in place by the Earth's magnetic field, so they follow the shape of the magnetic field itself. The problem with the Van Allen belt is that not the ability to pass, but the charged particles they contain. Charged particles are damaging to human bodies, but the amount of damage done can range from none to lethal, depending on the energy those particles deposit, the density of those particles, and the length of time you spend being exposed to them. for the Apollo trips. They wanted to send the astronauts through a sparse region of the belts and try to get through them quickly. This was necessary in any case. The craft had to make it to the moon in a reasonable amount of time, and the shorter the trip, the less exposure to all sorts of radiation the astronauts would get. In the end, it seemed that these tactics worked. The onboard dose counters for the Apollo missions registered an average radiation doses to the skin of the astronauts of 0.038 rad. This is about the same radiation dose as getting 2 CT scans to your head, or half the dose of a single chest CT scan. Not too bad, though not something you should do too often. And that's all we have for this episode of Astronomy Daily. Thank you for joining us. And remember, you can catch all the episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson, as well as the free podcast Astronomy Daily, at this address, spacenuts.io. So head over there and click the links and enjoy your fill of space, science and stuff. I'm Steve Dunkley, sitting in for Big Bro Andrew Dunkley while he is on hiatus. And thank you, Halley, for helping me out today while I'm still getting the hang of things. What's the plan for the rest of the day?
I'm heading back to the bit stream.
That sounds electrifying.
Last one in is a deleted file.
Bye, everyone.
Catch you next time.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.